Today we're looking at angles in triangles. So I want to do a quick review of the different types of triangles, the different types of polygons, angle properties, these sorts of things. So a scalene triangle has 3 different length sides, and it also has 3 different angles. On the interior angle. So all 3 of these angles are different, and all 3 of these sides are different. Isosceles has 2 sides equal and 2 angles equal. So the way that you show this is these 2 sides are of equal length. So you put a line like this. And then the 2 angles opposite those sides are equal. So this one across from here and this one across from here. For equilateral, all sides equal and all angles equal. And all angles so the length of this side equals the length of this side equals the length of this side, and this angle equals this angle equals this angle. An acute triangle has 3 acute angles, which just means that all 3 angles, this one, and this one, are less than 90 degrees. A right triangle has 1 90-degree angle, and it's denoted with a square. And then an obtuse triangle has 1 obtuse angle. So this is the obtuse triangle. So that just means 1 angle between 90 degrees and 180 degrees. So this angle here is bigger than 90 and smaller than 180. Then we have polygons. We have a square which has all sides equal and all angles inside, all interior angles 90 degrees. Then we have a rhombus, and a rhombus has, so these arrows mean that these opposite sides are parallel, and then these double arrows here mean that it's just to differentiate from these ones. These are also parallel. And then for a rhombus, also all 4 sides are of equal length. Then we have a rectangle, and a rectangle, we have opposite sides are equal lengths. So these 2 are equal and these 2 are equal, and all 4 angles are 90 degrees. Then for a parallelogram, opposite sides are parallel, sort of like a rhombus, and opposite sides are of equal length. So these 2 are of equal length and these 2 are equal length, but they're not necessarily all the same like they were in the rhombus. And then for a trapezoid, you have 2 sides that are parallel. So these 2 are parallel here. Then let's have a look at angle properties. Whenever you have 2 lines that cross like this, these 2 angles are going to be equal. So if this angle was 35 degrees, then this angle would have to be 35 degrees also. And then these opposite angles are also equal. So if this if this angle was 145, this one would also have to be 145. And whenever you have a straight line, like this, these two angles have to add up to 180 degrees. So A plus B equals 180 degrees. Inside the angles, inside a triangle, interior angles, always have to add up to 180 degrees, no matter what triangle it is. Then we have a bunch of rules for parallel lines. So when you draw a line through two parallel lines, it's called a transversal. If you draw a Z sort of a pattern like this, 1, 2, 3, then these two angles here, this one and this one, have to be equal, and they're called alternate angles. If you draw an F sort of a shape like this, so like a capital F, this is called an F pattern, then these corresponding angles here, so this one under here and this one under here, are equal. And then if you draw like a C sort of, like this, then this one and this one have to add up to 180. So another way to think of it is that if you draw a transversal through here, you're going to create a smaller angle and a bigger angle, and then a smaller angle and a bigger angle, smaller angle, bigger angle, smaller angle, bigger angle. And basically, if you take any one of those small angles and add it to a big angle, you'll get 180. And all of those small angles are the same. So this equals this, equals this, equals this. And all the big angles are the same. So this here equals the same as this, equals the same as this, equals the same as this. And that is for parallel lines. Next, I want to look at the exterior angles in a triangle. So if you draw a triangle like this and extend the three sides out like so, you can take any two interior angles. So let's say I take this one and this one. And if you add them together, if you take those two interior angles and you add them together, they will equal the exterior of the third angle. So this one plus this one, it doesn't equal the third angle, it equals the exterior of the third angle. And this is true if you take any angle. The sum of the interior angles, so like A plus B plus C, we talked about this already, will always be 180. And the sum of the exterior angles, so let's say D, E, and F, if you were to add this angle, and this angle, you would get 360. And lastly, if you take any interior angle and you add it to its corresponding exterior angle, you will get 180 degrees. Because this is a straight line here, so these two have to add together to make 180. So using these rules, let's solve a few problems. So we have this triangle here. This angle is 80 degrees, this is 40 degrees, and we're asked to find x. Now, we know that all three interior angles add up to 180. So we know that x plus 80 plus 40 has to equal 180. So basically we're just isolating for x. So we keep the x, we keep the 180 on the right side, the plus 80 and the plus 40 will subtract over here because the pluses become minuses on the other side. So 180 minus 80 is 100, minus 40 is 60, which means that x is 60 degrees. So this angle is 60 degrees. Let's take a look at this one. So these two lines are parallel, and that means that the little angles have to all be the same. And then the bigger angles, like these ones, have to also be the same as each other. So we can say right away that A equals 65, and so does D, because these are the smaller angles. And then to find these bigger angles, C and B, we know that the small plus the big has to equal 180. So we can do B plus 65 has to equal 180. So we take the 65 to the other side, and you'll get B equals 115. And because C is also one of those bigger angles, it will also equal 115. Okay, so A, B, C, and D. Here we have find angles A, B, C, and D. So let's do A first. So A plus 49 plus 53 that's the three interior angles, so they have to add up to 180. So to get A on its own, we'll take the 49 to the other side as a minus, and the 53 to the other side, and we'll do 180 minus 49 minus 53. And you'll get 78. So that means that angle A is 78 degrees. And then to find angle B, we know that these two together have to equal 180 because this is a straight line. So A is 78. Sorry, 78 plus B equals 180. So to find B, we need to subtract the 78 on the other side. So you'll get B equals 102 degrees. And then we can use the same process to solve for C and D. So C plus 49 also has to equal 180. So C equals 180 minus 49, which means that C equals 131. So angle C is 131 degrees. And finally, angle D, 53 plus D, have to add up to 180. So 53 plus D equals 180. So D equals 180 minus 53. So D equals 127. So now we found C, D, B, and A. So here we have to find z, and if you remember, if you take any two interior angles and add them together, you'll get the exterior of the third angle. So z has to be equal to 55 plus 65. So you'll get 120 degrees. So z is 120 degrees. Let's look at this one here. So to find w, so all three exterior angles have to add up to 360. So w plus 150 plus 70 has to equal 360. So to find w, we subtract these two numbers on the other side. So 360 minus 150 minus 70 is 140. So w is 140 degrees. And finally, we have this, find m here. So whenever these two sides are equal, then we know that these two opposite angles also have to be equal. So this is 25, which means that these two together have to equal 180 because it's an isosceles triangle with two equal sides and two equal angles. So m plus 25 has to equal 180, which means that m equals 180 minus 25. And 180 minus 25 is 155 degrees.